Welcome back. In this chapter, I want to explain about the character controller in Unity. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. Actually, character controller is a physics and collision component, which is very useful to implement a character movement, FPS character, first person character, or third person character, or any character movement stuff, and it is different from rigid body and regular object movement, and it offers some capabilities related to the characters, just characters, not general physics like rigid body. So here for the character movement, here add component and go to physics, and as you can see, we have a character controller component here, which is mixed with colliders and physics like rigid body, but it's better to assign it to a capsule. As I said in the previous parts, capsules are very useful for making characters, humanoid characters, because of its shape. Here's the head, a human head, hands, body, legs, and it is look like a human. And character controller, let's remove the capsule collider. Here, character controller is look like a capsule, and it is better to assign it to a capsule. Here we have some properties related to a controller, and let's explain the most important parts of it. Alright, the first one is the slope limit. So what it is? Actually, it is the maximum angle of the slope that the character can walk up. For example, if the slope is steeper than 45 degrees, your character will not be able to climb it and will be stopped or slide down. A value of 90 would allow climbing vertical walls, while a value of 0 would mean the character can't climb any incline. So it is 45. If I change the ground to this angle, this is higher than 45 degrees, it can't move up, and I need to change the slope limit of the character. And this is one of the benefits of the character controller. It can automatically detect the slope. Here the next is the step offset. Actually, this is the maximum height of a step that the character can step onto without jumping. For example, if a stair or ledge is 0.3 meters high, for example, the character will automatically walk up it. If it's taller, the character will be blocked. It is very useful for platforms and stairs and controlling them. And the default value is good. The default value for the slope limit actually is good as well. I will upload every chapter of the course every week. So make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. The next is skin width, and it's a small distance that determines how far the character's collider can sink into other colliders before being pushed out. Actually, a larger value makes collision detection more stable and prevents the character from getting stuck. And if it's too large, the character might appear to float slightly above the ground. Actually, a value between 0.01 and 0.1 is good. The default value is good and works. The next is mean move distance. The minimum movement distance that must be requested for the character to actually attempt to move. This value works, and you don't need to change it. But in some specific circumstances, you need to change the properties. For example, slope limit. If you want to create a character like Death Stranding, you need to increase it, because we may face with many mountain stuffs and hills, and the value of the slope limit must be increased in those cases. The next is the center or the position of the collider. Here we can change the X, Y, and Z. You're familiar with it. I've explained it in the colliders section. Here we can increase the radius. If I lower it, as you can see, the height doesn't affected by the radius, but with the higher values, the height affected by the radius. And here we can change the height. And I don't want to explain the layer over it. It's a general field that I will cover later. As you can see, it exists in the other colliders. Alright, let's write a simple code to move the character using the horizontal keys and vertical keys. Here, let's add a new script. Call it character movement. Here we have the start and update by default. Right here we need to declare an object of type of character controller, right, and name it controller. In the start or awake, we need to get the character controller component. I wanna assign this code to the capsule, and here let's assign it at first. And here we can call the get component method to get the character controller. I've explained about the get component in the previous part. Controller equal to get component and the type of component we want to get, character controller, and call it. Here we have, let's save it. We have the character controller at the start. Let's play and test. Here it's a field. Let's play. Alright, as you can see, we've get the capsule character controller. Right, in the update, we need to get the inputs and move the character because we wanna execute it every frame. Here, let's call the controller, and it has two main methods: move and simple move. Actually, we can change the properties of the controller, for example, slope limit, min, move distance, and so on. But the method we want to use is move. And we need to pass a vector tree, just a vector tree, to the move. And here we need to pass the vertical for the Z, and it is a forward. Or you can pass for the X, vertical for the X, W, and S keys. I'm gonna pass the vertical for the Z axis and the horizontal or A and D keys for the X axis. In the previous chapter, I've explained about moving the rigid body using the vertical and horizontal key. And if you don't know about the horizontal, vertical, and physics, you can watch the previous sections first. So here we need to create a new or inline vector tree, new vector tree, or we can declare a vector tree up here. For the X, I need to get the input dot get axis horizontal. For the Y, 0 is good, and for the Z, I need to input get axis vertical. Alright, this is not similar to the rigid body, and we don't need to get the current character controller or object Y axis and position and set it here. Actually, move is similar to the translate method in the transform class. From the transform class, it will add a value to the current position of the character based on the physics, and it will not ignore the physics. Looks like the translate method. From the transform doesn't affect on the physics, and it's not based on the physics. So here we need to save and execute the game. Here, play the game. Here, let's play the game, and as you can see, I'm moving the capsule collider with W, S, and D. We don't have gravity here. Actually, character controller doesn't have a gravity feature, and we need to implement the gravity ourselves manually. And it's not too complicated. First, we want a gravity multiplier, a value that multiplies by the y-axis, because we want to apply the gravity based on the y, along the y-axis. So we need a multiplier that that's the force and the speed of the gravity. Here I need to declare a variable, a float, and call it gravity multiplier, and the value I'm using in my project is negative 30.81 F. And you can use other gravity values. You can search on the internet and use some constants that physics offer you. Here we need a property called velocity. Controller has a velocity. Velocity is a speed and a value that every axis has. For example, if we move the character in the x-axis, we have a positive velocity. If we press A key, because the horizontal keys are related to the x, if we press A key, we have a negative value of the velocity for the x-axis. And if we call the velocity property, we can get the axis speeds and use. But I don't want to use the velocity of the controller. I want to declare my velocity. The velocity is a vector tree, as I said, and name it velocity. Here I want to change this velocity and set the character to this velocity. Actually, with calling move, we are changing the velocity property of the character. So here we want to change it again, but I will use this field just for gravity. Here the only axis I want to change is the y. So I need to call the velocity.y, because the gravity should be applied along the y-axis. So we need to call the y and use the plus equal, because I want to add a value to the current value of the y. So the value I want to add is the gravity multiply. And here we need to call the controller.move again, but this time for gravity and the y-axis, not for the x and z. And here we need to pass the velocity, and this vector tree will be added to the move, and the x and y is 0x. Alright, let's see. Play the game. Alright, as you can see, the capsule is not on the air. Let's move it, and as you can see, I can't. We have a gravity here. I can change the position of the plane, and as you can see, the capsule is coming with it. And I can reduce the force of the gravity and change it to this value and try again. Right now we made it slower. As you can see, the capsule is falling down slowly than the previous value. Another concept is a time.delta time. Time class dot delta time variable. It's a float variable that gives us the execution time of every frame. It's not constant because every frame can be vary, and the execution time of every frame can be vary, and we can multiply this value by delta time, or this value by the delta time, to synchronize execution of the character movement, because the character movement is a sensitive work and we need to do it based on the delta time. Consider we have frame drops in the games and some issues, and actually we have a constant character movement speed for each frame, and this is not good. We need to multiply this, for example, this variable for a frame is 0.001. So we need to multiply this by this vector tree, and it will synchronize and normalize the value, and it will change this character speed based on the frame rate. And this is very useful technique. It is necessary for every game. So here we need to multiply this vector tree by time dot delta time. The question is, can we multiply a float value by a vector tree? Yes, it will automatically multiply every axis, x, y, and z separately by the delta time, and the vector tree values will be affected by this value. So we need to do it for the gravity as well. And now let's test. Our target is to normalize the speed of the character. Alright, here in the game view, if I press the controlling buttons, the moving buttons, as you can see, the character movement is slower because we multiplied it by the delta time, but it is variable and it will change based on the frame rate. And let's test the gravity as well. Alright, it is good. Also, we can declare a variable called speed, float movement speed, and set it to 1. Here we can multiply the vector tree by the movement speed at first, and next the result multiplies by the delta time, and it will normalize it. Here also we can modify the speed of the movement if the movement speed is not enough for you. Alright, here we can change it. Let's play the game and change it at runtime. Right, as you can see, we have a movement. Let's set it to 3, and here this is faster. Right, we can make it more advanced and add a shift key and get the shift key using the get key down or get key up. And if we press shift, we can set it to 6 or 10, and if we release the shift key, it will set to 1 and revert it back. And here we have a running instruction in the code. In the next part, I will explain about how to make a more advanced character which has a camera. I will explain the camera, changing the character direction based on the camera, and so on.